Hi everyone, welcome back to my channel. In this problem, I'll show you how to verify or how to prove that sine of a minus b over sine of a plus b is equal to a squared minus b squared over c squared. If you are new to this channel, please consider subscribing to support my channel and my work. So, how do we go about this problem? We can realize that the problem or the functions are in terms of sine, and so we are told that A, B, and C can be angles of a triangle, and then A, B, C, small case sides of a triangle. So in such a case, we are considering that you have a triangle such that if this is angle A, then the corresponding side is A, and then if this is B, then the other side is side B, and likewise if this is C, the side is C. So then we can combine two things here. One is the cosine rule that applies on a triangle, and then we can also apply sine rule that applies to the triangle as well. So these rules are in the form of that, like if you have side is A, this is squared, is going to be this other two sides squared, that is b squared plus c squared minus 2 bc, then cosine of the angle that is opposite to that side. And so this can be manipulated in terms of whatever you want. For example, if we want for the angle b, then we can say this is b squared is equal to a squared plus c squared minus 2ac, then cosine of b. So I'm rewriting these two because I'm only interested in angles of A and B, and then the C will just come in automatically as the length of the third side of the triangle. And then if we try to talk about the sine rule for the triangle, then we can talk about of either sine of the angle A over side A is the same as sine of B over side B, and this is equal to sine of C over C, and so on, which is a constant. So these are going to form the basis of our proof. So now, how do we get started once we know all this information? And we can always know this information based on the fact that one, you have some prior knowledge about what you're doing, and two, you need to know how to apply some of the trigonometric identities or like formulas for the compound angles. So from here, beginning from the left hand side, we are going to say we know that sine of A minus B over sine of A plus B. We are going to expand this, and this is going to give us sine of A cosine of B, then minus sine of B cosine of A, or cosine of A sine B, whatever comes first, it's a product, and then over sine of A cosine of B, then plus cosine of A, then sine of B. So this is what we have if we apply the compound angle formula for the sine, and then this is going to give us this. So now what we have to ask ourselves now, we have this from what you can see from above here. When you are using the cosine rule, we can get cos of A, we can get cos of B, and we see that this is cos of A, and then this is cos of B. So that means we can make a substitution of what is this. And the other reason why we are referring to this is that what we want to come up with includes the sides of a triangle. So that is why we are making a use of these two rules that have both angles and then the sides. Now from here we can go up here and then try to make cos of A the subject, and then so what happens is that I'm just going to make sure that I rearrange these two equations, get cos A, cos B, and then so we can see that to get cos of A, this is going to give us I'm going to take this term, the other side, and then bring this side and divide by 2bc. So that means I have b squared plus c squared, then take off a squared, and then this is divided by 2bc. And then the same idea applies on b. Let's do the same procedure, and then this is going to be cosine of b being equal to, so I'm going to take this on the left side and then bring this to this side, and then we divide by 2a, and so that will give me a squared plus c squared minus b squared, everything divided by 2ac. So these are the equivalents of cos A and cos B. And then also we can see that we need sine of A both up and down. We may not be able to get sine of B, but we can express sine of A in terms of AB and then sine B. So let's do that. And so this means we have sine of A being equal to A over B sine of B. So what happens now next is that we are going to grab all these three and substitute them here, and so this is going to give us sine of A, which is this one. This is going to be A over B, then multiplied by sine of B times cos B. Cos B is already here, and this is going to be A squared plus C squared minus B squared, everything over 2AC. Then take off sine of B. We don't have it, but you can keep it, but you have cos of A. Cos of A is already up here, so this is going to be into B squared plus C squared minus A squared over 2bc, then multiplied by sine of B. Just keep it. Then everything, this is divided by the same stuff but with a plus sign. So I'm just going to duplicate what is up, and then this is going to be A over B sine of B, then multiplied by A squared plus C squared minus B squared over 2AC, then plus this is B squared plus C squared minus A squared, everything over 2bc, then times sine of b. Observe that what we have here, the sine b is everywhere. It's a common factor, so we can pull it out and cancel that, or we can just cancel it directly everywhere since it's common. And then we can also observe that a is up here, so it can cancel with that, right? So this doesn't cancel with anything, and also down here it can cancel. So in other words, I remain with something like a squared plus c squared minus b squared, this is squared, over over 2c, but times a b, so that becomes also bc, then minus what we have here is b squared plus c squared minus a squared over 2bc. Now, so this is what we have down up, sorry, and then I think I should put this on a bigger part. Let me erase that, and then I'll just put this somewhere here. So when we do that, we have sine of b is gone, sine of b is gone here, everything, a has cancelled up and down, so we basically have a squared plus c squared minus b squared over 2bc, b, c, and a 2, then take off b squared plus c squared minus a squared, everything over 2bc. Then the entire thing is divided by the same but with addition, so this becomes a squared plus c squared minus b squared over 2bc, then plus b squared plus c squared minus a squared everything over 2bc. Observe that what we have up is on the same LCM. Then we are going to try to organize what is up, the numerators, but this is in brackets, and you can observe that we have a minus here. So let's open up the bracket. At the same time, let's try to collect like terms. So when I open up here with a minus, this is going to be minus b, and this is a minus, so that will give us a 2 minus 2b. But then when we check on c, this is going to be minus c, and so it will cancel with that. And then minus into minus, a that goes to positive, so it adds on that. So basically this is going to give us 2 a squared plus sorry, to be minus so it's going to be minus uh, minus 2b squared, because this is minus b, so that goes to that, and then this is minus c, which cancels with that, and this is over 2 bc. So that's the upper part, right? Then let's look at the lower part. The lower part is almost the same, but the only difference is that we are adding here, and so let's see what happens when we add. So this is over again to bc. So when you add, you can see that this is a squared, and this is minus a squared, so that will cancel with that since we have the same denominator. And then when we look at minus b, this is positive b, so this is going to cancel with that. So basically what is surviving in the denominator is the c squared that forms the 2 c squared. So now this is basically what we have now, and let's try to simplify. The 2's can cancel. If you factorize out the 2, can go with that. And then we basically have a squared minus b squared over bc. Then this is divided by what we have here, which is the 2 can go, which is the c squared over bc. And then the idea is to multiply by changing this, switching that up and down. So this is going to be a squared minus b squared over bc, then multiplied by bc over c squared. So this goes and that, and then we finally have a squared minus b squared over c squared as being equal to sine of a minus b over sine of a plus b equals that. So thank you guys for watching. Please consider subscribing, share, like, leave a comment. Thank you so much.